Okay, if you're seeing this right now, I'm in Reno. Um, I don't know how much this video is going to help. I have a YouTube channel, and I think the videos on my YouTube channel have like 4 views total. So I'm definitely not an influencer. But what I want you to do is in Canvas, there is a document that accompanies this. It's called Worksheet for week 7, day 1, I think. Anyway, and you're going to follow along with me. I don't know how much information I'm going to give you. I may just tell you what to do and set you at it. Or I might just say heck with it all and we just have a nice little 4 week long vacation. All right, well, let's just see what we get here, huh? All right, a little bit of funniness. All right, if you didn't get it, you get an F in the class, okay? All right, here's a scenario. We've got 3 prospective teachers, and they were planning a unit of trig as a part of their work in Math 323. And they developed a plan in which high school students would first encounter what the 3 future teachers called the 3 basic trig functions, which are sine, cosine, and tangent. You may have heard of them. They may be your best friends. The 3 prospective teachers indicated in their plan that students would next work with the inverse functions, which they identified as secant, cosecant, cotangent. Now, what do you notice? How is their math, and who are these prospective teachers anyway? So on your worksheet, this is slide 3, I believe, and you can go in there and basically you're asking yourself, is cosecant the inverse function of sine? Now notice I'm saying function, saying inverse function. So you'll need to think about that for a little bit. Is sine a function? Does it have an inverse? If so, is it cosecant? And do that for all 3 basic trig functions. I want you to think about this mathematically. And if you have any idea who these jokers are, let me know so I can talk to them. Okay, so you're going to write that under slide 3 that says scenario. So we've got some definitions here that you need to get into your notes for slide 4, one-to-one function. Some of you may have had in a class like, what is it? If x equals y, then f of x equals f of y, or vice versa. I can't remember which one it is from like a number theory class. But what does it really mean? What are we focused on as we're looking at a one-to-one function? Maybe we've got 2 sets, set A, set B, and there's some doodads in here, right? And there's some doodads in here. There's a lot. That's a big doodad, and maybe a little smaller doodad. How would these be assigned so that we knew it was one-to-one? And what set are we focusing on when we're trying to decide if something's one-to-one? Okay, and then again, going back to that definition, if f of x equals f of y, then x equals y. I think there's a hint there. What is an inverse function? What is an inverse function? So inverse function, and it's important to think about what is the domain and what is the range. These, wow, doctors, like Dr. Pepper, the domain and the range. And then composite function, remember we're going to take function 1, so maybe this is function 1. h of x. And then we have, makes that look more like a g. Kind of looks like a g, not really. It looks like a broken 8. Doesn't matter. G of x. And somehow we're taking something and running it through this function, and then running it through this function, and coming out this side. Talk about it. What's the domain? What's the range? These sorts of things. And again, remember, who are you defining this for? You're not defining it for your professors. You're not defining it for a test. You're defining it for your students, estudiantes. Okay. So now, here's some questions I want you to answer. And I want you, like for this first one, how do you test that one function is the inverse of another function? Use the vocabulary on the previous slide to do that. Another one, how might you use a table to show that a function is the inverse of another? Again, get at the concept, what's an inverse function, and then use a table to show how you might actually show a high school student that one function is the inverse of the other. And then how do we use those graphs to show that one function is the inverse of the other? Okay, so we're thinking about how do we, one way we could test them, one way we could show, and the other way we could show that a function and another function are inverses of each other. Okay, so in your answers, in the little worksheet that you're going to do, I would like some pretty pictures, and I'd like lots of really awesome sauce explanations. Okay, so now here is a true and false and why. Now we're living in function land, and when I see the word inverse, so inverse, they're like, wow, you can write, no, not very well. Inverse and inverse function, and I'm just going to use INV period to, and then FCTN for inverse function. Inverse function, I'm not sure that they're equivalent. I'm really not. But we use this word inverse, and a lot of times we use it to cover both things. The inverse, whatever that means, and then the inverse function. And I think this one is talking about an operation versus a function. So you're going to need to clear all that up, because these are, the answer to all of these is no if we're living in function land. So you need to tell me why that's so. Okay, this is like the bane of my existence, and it's really kind of crazy funny. Just last year, my daughter was in her Algebra 2 class, and her teacher said, oh look, these two graphs are inverse functions. Now, going back to the slides, remember you need to know, when does a function have an inverse? There are some characteristics of that function that it has to have to be an inverse. And we look at that function right there, and then we say, do we have those characteristics in that function? Okay, so I want you to say true or false and why. And remember that if you get the wrong answer, I'm probably going to lose more hair. So please don't get the wrong answer. No, I'm just, stop. Okay. But this one, I actually saw this picture in a high school book. And oh, FYI, that does not mean it's correct. It just means it was in a high school book and some author put it in. So when I'm talking about transformations, I'm talking about geometric. Just thought I'd write for you. You're like, wow, you can mostly write. Geometric, that's what I'm talking about, transformations. Now, all of you had to have geometry. All of you did geometric transformations. So are they functions Do they have an inverse? Are they one-to-one? Can you compose two transformations? And why am I asking you this? I need some good pictures and some good reasoning here for you to get credit, credit, credit. And I feel like one of the, and then why am I asking you this? Why would I be worried about this? I want you to think like a teacher. Why would I, all the things we've talked about so far are more algebraic. And all of a sudden I'm jumping into geometry land. Why am I asking you this? Okay, so you've come to the end of the video. You're like, yes. You still need to answer those questions. Those questions are going to need to be answered and submitted in Canvas. Okay, but you can just type them right into the little Word document. And then for Wednesday, if your last name starts with A through H, you need to read that article. And if it starts with K through Z, you need to read that article. And your job is to be a teacher, to be a colleague, to be professional. And so I want you to read and ask yourself, what's the important mathematics that was discussed in the article? What teaching methods, if any, were present in the article? And would you use this information from the article in your teaching about functions? Yes or no, and why? Okay. And in your worksheet, I want you to write down your answers. Okay, please. And actually, excuse me. I would edit that out because I did pay for the editing capabilities in this program, but not gonna. On Wednesday, for your worksheet on Wednesday, you're gonna record your findings. Okay, and I'm expecting some well thought out answers. Okay, so you've made it through Monday. I'm probably at the table shaking my head, thinking, "Look at all these people throwing all this money away. The odds are against them," and you're laughing at me. I'm gonna bring home a T-shirt for everybody that says Dr. Windsor went to Reno and all he got me was this stinking T-shirt. All right, do your homework and watch the video by Wednesday, or you can watch it tomorrow. Who knows? All right, talk to you later.